do. Hey guys, this is Mrs. Lyons. Two things that I want you to see. I want you to take a look at this list of polyatomic ions, not polyatomic lions, polyatomic ions, and our activity series. Just take a screenshot of these right now so you have them to work the problems that you have to do. I will get a copy of this to you next time I see you in class. All right, so the first video that we go over, or that I go over, is going to be going through kind of quickly synthesis and decomposition reactions, okay, predicting products. All right, and I'm just going to do all of them, and I'm going to do them relatively quickly because hopefully you guys will be getting better at this. And if if you're not sure what's going on, that's when you ask a question in class or you shoot me an email. All right, so synthesis, we're going to combine two things in two elements into one compound. So barium plus oxygen would be barium oxide. Okay, if we write that into a chemical formula, we would have barium plus oxygen gas. Oxygen's one of the Haber-Finkel 7, produces BaO. Okay, barium has a +2 charge, oxide has a -2 charge, so those cancel out. In single replacement reactions, the products that you make are going to be solids, okay, if they're ionic, which I think they almost always are. All right, if I wanted to balance this, I would put a 2 here because I've got 2 oxygen, and then I need a 2 here, a 1 here. All right, magnesium plus sulfur produces magnesium sulfide. All right, magnesium is Mg, it's a solid. Sulfur is a solid. We produce, magnesium has a +2 charge, sulfide has a -2 charge. So we're going to be producing MgS because those cancel out. Synthesis products, if they're ionic, they're going to be solids. So that's something I want us to kind of get used to seeing. I have had you identify the elements as solid, liquid, gas, but I also want us to start identifying the compounds. So in a synthesis reaction, actually in synthesis and decomp, okay, ionic compounds are solid. Okay, so keep that in mind as you're going through these. All right, next we have fluorine plus calcium. Okay, so this is done to kind of trick you up. Okay, you got to remember calcium here is the metal, so calcium is going to go first. So calcium iodide, changing the ending to IDE. All right, so we have fluorine, which is one of the Haber-Finkel 7, the diatomic elements. It's a gas plus calcium solid, reacts, combines to produce Ca. Calcium is +2, iodide is -1. So CaI2. All right, potassium iodine. All right, this case potassium is the metal. We're going to produce potassium iodide. All right, in this case, potassium has a +1 charge, iodide has a -1 charge. So we're going to start with potassium plus iodine, which is one of the Haber-Finkel 7. Iodine is a solid. Don't forget that. All right. Remember, there's only 2 liquids, mercury and bromine, and then gases that we're going to see hydrogen, nitrogen, oxygen, fluorine, and chlorine are going to be gases. Everything else is going to be a solid when you're talking about the element. So this is going to give me Ki because they're both 1 solid. Oh, shoot, I forgot to balance. This one is balanced. Let's see. Sorry, guys, I completely screwed up, didn't I? I got all carried away and wrote calcium iodide. My whiteout is broken. All right. So let's try that again. My bad. At least I caught my own mistake. Calcium fluoride. Okay. So that's going to be CaF2. All right. And I guess this is already balanced just the way it is. Okay. Sorry about that. Potassium plus iodine gives us potassium iodide. We need a 2 there and a 2 there. All right. Aluminum and phosphorus is going to produce aluminum phosphide. All right, so we have aluminum solid. We have phosphorus solid. Neither one of those are diatomic. And we produce aluminum forms a +3 ion. Phosphide is a -3 ion, so those cancel. Also, this is another sweet one. That one's already balanced with 1s. All right. Moving on. Bromine and sodium. Sodium is the metal here. So we end up with sodium bromide. All right, sodium forms a +1 ion, bromide a -1. So we're going to have bromine. Bromine is one of the 7 diatomic elements, so Br2. Bromine is one of the only 2 liquids on the periodic table. And then we have sodium, which is a solid, and we produce sodium bromide solid. All right, let's see. So we have 2 bromine here, so I need a coefficient of 2 there. And then a 2 in front of sodium. I am going through this quickly, so if you need help on balancing, let's set up a time to do that. All right, gallium plus chlorine is going to form gallium chloride. Okay, gallium forms a +3 ion. Chloride is a -1. So we start with gallium solid plus Cl2. It's a Oberfinkel diatomic. That is a gas. And we produce GaCl3 solid. Here's one of those situations where you've got 2 on one side and 3 on the other. You got to get a least common multiple of 6. So if I take this times 3, 3 times 2 is 6 chlorine. If I put a 2 here, 2 times 3 is 6 chlorine. I have 2 gallium, and I'm balanced. All right, lithium plus nitrogen forms lithium nitride. Okay, lithium forms a +1 ion, nitrogen a -3. So I have lithium solid plus nitrogen N2, it's a diatomic gas, produces Li3N solid. All right, let's see. So I've got 1 nitrogen here and 2 here, so I need a 2 here. And then I have 6 lithium, and I'm balanced. All right, oxygen and strontium. Strontium is the metal. So we end up with strontium oxide. Strontium is +2, oxide is -2. So we have O2, oxygen gas, plus strontium, which is Sr, solid, reacts to give us SRO, solid. We need a 2 because of the 2 oxygen, which means we need a 2 in front of strontium. All right. And I know I'm going through these quickly, guys. I'm going through them just to kind of give you a quick answer key to show you how you should be doing these. If you have questions, come in and talk to me. All right. How many of these do we have? Lots. Good Lord. All right. Sodium plus phosphorus is sodium phosphide. Okay. Sodium forms +1 ions. Phosphide is -3. So I have Na solid plus P solid produces Na3P solid. If I put a 3 here, I'm balanced. Silver plus iodine forms silver iodide. Silver, remember, silver always forms +1 ions. That's one you have to remember. Iodide is -1. So we have Ag, solid, plus I2. It's one of the 7 diatomic elements. It's also a solid. Produces AgI, solid. We've got 2 iodine on this side, only 1 here, so I need a 2 in front of there, which means I need a 2 in front of silver and a 1, and I'm done. Zinc plus nitrogen forms zinc nitride. Okay, zinc is +2. That's another one of the transition metals. It always has the same charge. Nitride is -3. So I have zinc, solid, plus nitrogen. Nitrogen is one of the diatomic 7. So it gets a 2. It's also a gas. And we're going to produce Zn3N2, solid. So let's see, my nitrogen is balanced. I just need a 3 here to make up 3 zinc. I already have 2 nitrogen on each side. Potassium chloride. Aha, check it out. This is a decomposition. It's a compound. We've got to break it down into its elements. So potassium chloride is going to break down to form potassium plus chlorine. Remember, you have to change the ending back when it goes from being an ion to an element. IDE tells us it's an ion. Okay? So just by the way, 1 through 12 were all synthesis. We're putting 2 things together. Now we've gotten into the decomposition. All right? So potassium chloride, potassium's +1, chloride is -1. So KCl. And this Cl, guys, this does not get a 2 because the diatomic elements only, the Hoberfinkel rule, the diatomic elements only happen when it's the element by itself, not when it's combined with another type of atom. That's a compound. And that's when we have to look at the charges. So potassium chloride breaks down to give us potassium solid, plus chlorine is a diatomic now that it's by itself, and it's a gas. So 2 chlorine over here, I need a 2 to give me 2 chlorine, and I need a 2 to give me 2 potassium. Iron 3 oxide is going to break down to give us iron, plus, don't forget the plus sign, oxygen. All right, iron is +3, oxide is -2, so we end up with Fe2O3, solid. And that breaks down to give us Fe plus O2 gas. So we've got 3 oxygen over here, 2 over here. We need the least common multiple of 6. So if I take this times 3, 3 times 2, I get 6 oxygen. If I take this whole thing by 2, I get 2 times 3 is 6 oxygen. And 2 times 2 is 4 iron, so I need a coefficient 4 there. All right, sodium sulfide breaks down to give us sodium plus sulfur. All right, sodium forms +1 ion. Sulfide is a -1 ion. Oops, sorry, sulfide is a -2 ion. So we get Na2S, solid, breaks down to give us Na, solid, plus S, solid. So there's a 2 in front. There's 2 sodium, so I need a coefficient of a 2 here to get my equation to balance. Magnesium nitride breaks down to give us magnesium plus nitrogen. Okay. Magnesium forms a +2 ion. Nitrogen is -3, so I crisscross those. I get Mg3N2. Breaks down to give me Mg plus nitrogen is a Hoberfinkel. It's diatomic, and it's a gas. So nitrogen is already balanced. I've got 3 magnesium. Calcium chlorite. We do not have to do chlorites. We do not have to do hydroxides. We do have to do carbonates, but carbonates are easy. Remember, carbonates break down to give the metal oxide, so lithium oxide plus carbon dioxide. Okay, so lithium has a +1 charge, carbonate is -2. So lithium carbonate is Li2CO3, right? Still a solid. And that's going to break down to form lithium oxide. So lithium still +1, oxide is -2. So Li2O, that's an ionic solid, plus carbon dioxide is CO2 gas. Like I said, these are super sweet because they're always balanced if you predict the right products. All right, silver fluoride. We're back to a normal decomp. Silver fluoride produces silver plus fluorine. Silver's +1, fluoride is -1, so I have AgF, solid, produces silver solid plus fluorine is a Haber-Finkel diatomic. It exists as F2 gas. So I have 2 fluorines. I need a 2 here, a 2 here, and I'm balanced. No chlorates. We're not going to do chlorates, so we can skip that one. Zinc phosphide breaks down to give zinc plus phosphorus. Zinc is +2, phosphide is -3. So we have Zn3P2 produces Zn solid plus P solid. Neither one of those are part of the Haber-Finkel 7, so they're not diatomic. So all we have to do is make this 3, so we have 3 zinc, 2, so we have 2 phosphorus. All right, whew, that was a lot. Are we done? We're almost done because we do not have to do copper hydroxide, but let's do nickel to bromide. All right, this is a simple decomposition, breaks down to nickel plus bromine. Nickel, the Roman numeral tells us is +2, bromide is -1. So we have NiBr2 produces nickel plus bromine is part of the Haber-Finkel 7. It's one of the 2 liquids on the periodic table. So check it out. This one's already balanced. Okay, that was really speedy, guys. That was a really quick run through of how to do synthesis and decomposition. Hopefully that helped. Have a great day, night, weekend, wherever you are, and I will see you in class. I did that whole thing without recording.